Welcome students, and we are continuing with the type of sets, and we'll let's look into the equivalency property between when we compare two sets. So what do you mean by an equivalent set? Of course, this property comes up when we are comparing more than two sets or more than two sets. So what do you mean by equivalent sets? So equivalent sets means that the sets which we are comparing have equal cardinal numbers. That's the countable number of distinct elements of the sets being compared are equal. That's which means that if you are dealing with two sets A and B, then NA is equal to NB, and quite a similar property is being explored in what is called equal sets. And equal sets means that the elements of both the sets are equal, in the sense that every element, if we are comparing two sets A and B, then every element of A ought to be in B and vice versa, which means that every element of B also must be present in A. Let's look at a particular example to drive home the point. We are comparing three sets of A having elements A, B, C, D, B having elements C, D, E, and C. The elements are not English letters, but they are natural numbers. It's 2, 4, 5, and 6. Now, we can see that A has 4 elements, B 3 elements, C again 4 elements. But now, is are any set being equal? Are any set equal to any other set? Answer is it's not possible, because you may say that A has 4 elements and C has again 4 elements, so they are equal, but we can't call them equal sets, because the character of the elements are different, which means that C is dealing with natural numbers, countable numbers, and A is dealing with the letters of English language. So it's not possible. So, but A and C at the same time has uh, equal cardinal numbers. That's the distinct elements in A and of both A and C are equal, which means that A and C are equivalent sets, even though they are not equal. So you can see how the difference is coming up, which implies that equal sets need not need not necessarily be equivalent. Now let's go into one of the most important type of sets. In fact, type of set relation when we deal with comparing sets, and that's what is called a subset. Subset simply means that if you are comparing two sets A and B, and if all the elements of set A is present in set B, then A is said to be a subset of B, which simply means that in a manner it implies that A is contained in B. And if you look at an arbitrary element and take it as small a, that's an element of A, then naturally that element ought to be present in B. But this condition simply also means that it isn't necessarily true, or there's no need for the condition to be true in the other direction, which all it means that every element of B is not necessarily present in A. So A can contain anyway B will be containing all elements of A. That is something which we are sure. But B can also contain more than the elements which A contains. So that's the point of it. So if so there are two conditions coming up. So if X is an element of B, then there are two conditions. So X is an element of A, and it is also a possibility that S may not be an element of A, in the sense that B is having more elements. So you can see a very simple example here. Set A contains 4 English letters C, D, E, F. That's 4 elements. B contains 5 elements. So A is of course a subset of B, but you can see that B contains one more element than A. So that's the meaning of subset. And naturally, when we are dealing with subset, what is the reverse relation? The reverse relation is what is called the superset, and the notation is the symbol is drawn in reverse. So it means that if A is a subset of B, then B is denoted as a superset of A. Oh, in a manner, it implies that B contains A. Let us look at another kind of very interesting set, and this set has its origins, or comes into being because of the mathematical premise or the particular definition. And that is exactly why we call it an improper subset or improper subset. Actually, there are two subsets. So, for a given set A, it has two subsets. So that's interesting. One is the void set or the empty set, and the next one is the set itself. So any set, it simply means that any set would be having two subsets by means of the criteria of definition. And because of it's coming up like that, we call these two sets improper subsets, which leads us to the point of what do you mean by proper subset. So a proper subset simply means that it's not simply by means of any criteria or a theoretical perspective. So proper subset simply means that for a set A, if it's a proper subset of set B, it simply means that A is not equal to B. So that's the meaning of it, which simply means that we know that subsets mean that every element of A ought to be present in B. Here, so if it's stated A is not equal to B, then it means that B has more. It implies that B has more elements, and that's exactly what is stated here. That's considering an arbitrary element of B, if you call it at X, and X is an element of B, and such that X naturally will not be an element of A. And to wind up this particular video, this particular section, there are two interesting points coming up. One is if A is a subset of B, which simply means that A contains all elements of B. Sorry, A contains it means that A has elements which are all contained in B, and if that condition is also true in the reverse, that means B also. That means the elements of B are also present in A. That simply means that A should be, or set A should be equal to set B. The next one is one of the fundamental subset proper subset properties which we see in the number systems, and it's quite simple at the same time, has a lot of significance and importance. And of course, I'm sure most of you, if not all of you, would be knowing what those capital letters are standing for. They are the sets of different number systems, and we start from natural numbers, which is the set of natural numbers, which is a proper subset of Z. That is the set of all integers, which is a subset of Q, as a set of rational numbers, which again, it's a proper subset, which again is a proper subset of R, that's a set of real numbers, and the whole in a manner, this proper subset business ends with C as a set of complex numbers. Thank you.